computer. Okay. Before starting, and we were here, before starting, let us remember the formula. If you remember, the formula was exponential decay. Let me show you quickly here. There were two formula. Yeah. Here we have exponential growth or decay. N is equal to last case, at the end of the operation, at the end of the years, whatever, and 0 is the starting point. So when we start the problem, 1 plus r to the power of t. T is the time in general of the years, and r is the rate. If r is greater than 0, we have a growth, it's increasing. If r is less than 0, it's a decay, it is decreasing. And in the question, if we have continuous exponential growth or decay, when it says the keyword continuous, we use the formula n0 times e to the power of k times t. And then n0 as it is here, same thing, initial and the last case. Here just the e is, it is a number e, it's 2.71, 2.72, whatever, approximately one number. And k is the rate like r, it's same. And if k is greater than 0, it's growing. If k is less than 0, it's decaying, decreasing. T is the number of. Okay. Now let's continue with our example after the formulas. Yeah, this is now our question. The table shows the population growth of deer in a forest from 2000 to 2010. If the number of deer is increasing at exponential rate, so it is given here, exponential rate increasing, so we can say that r is greater than 0 here. And then identify the rate of increase and write an exponential equation to model this situation. So how can we write mathematical formula to express this case? Year is 2000, the number of years 125. So it's clear that the n0 in our formula, the starting point. And then year 2010, it is 264. It could be n. And year from 2000 to 2010, how many years pass? It is being t. Okay, let's go on. If we let nt represent the deer population t years after 2000, assume the exponential growth, then the initial deer population is n0 is 125, and the time 2010 minus 2000 is equal to 10. So after 2000, how many years are passing? 10 years are passing. The deer population will be NT is 264. Use this information to find the rate of growth. So if you write the formula, ladies, this is our formula if you remember, and n times and 0 times 1 plus r to the power of t. So with respect to t, this is growing. The number of deers are growing, increasing. So in our question, since initial one is 2000 and the last one is 2010, t must be 10, and the last value 264 we are writing, starting point we are writing here, 1 plus r to the power of 10. I mean, till here, I do not think so. Till here, I do not think so. There's a problem. Everything is clear till here. Okay. Now the problem is this, how can we find R? So if this is, imagine 264 is equal to 125 times 1 plus x, it's easy to find. It's easy. Why? This is linear function, first degree function. It is simple, but we don't have this. We have R to the power of 10. Since we have R to the power of 10, what can we do? Anything?
Teacher, what if you divide 125 by the both sides?
Then we will do that one. So let us see on here, 264 divided by 125. Till here, it's also okay. I am talking about this exponential.
I see you will square root of 10 both sides.
Yeah, we will do. It's not difficult, I know, but it's not as simple as like this. It is not linear, it's exponential. And then 264 divided by 125, 1 plus r to the power of 10. When we take the 10th root, okay, we say that 10th root of 264 over 125 is 1 plus r. And then by using the calculator, okay, we can take the one other side. And then by using the calculator, we got this. Can you use your calculator, everybody? Can you use your calculator? Can you get this result or not? Please do this now. Do you have the calculator which, which takes the 10th root?
They give me 1.077.
Let me do also in my calculator.
I got the same answer.
Yeah, I
You
got the
got the
same
same
answer.
answer. Okay, very good. Then if we got the same answer, there's no problem. It should be. I am asking that since in the examinations or quiz you need this, so you should learn right now how to do it. So it's time to make a practice. Yeah, I got 0.0776 in my calculator. It is 0.077629. So if we take the 3 digits, that means till here, what can I do? Since 6 is greater than or equal to 5, so I am increasing before, so 0.078. Okay, good. I don't think so. There's a problem. It's just calculation, and it's not difficult here. Now let's go. So what can we say after this result? What can we say after this result? R is equal to 7.8%. So this is decimal number. If we multiply this by 100, we will get the percentage. Is there any problem for this? How did we get from this?
No,
No,
no.
it's so clear. And then, since our question says that make a model, I mean, write an expression gives us this exponential growth as a formula. So we can say that nt is equal to n0 and 1 plus r, since r is 0.078, and do not forget when we write the r, always use the decimal number in the formula. So 1 plus 0.078 to the power of t. So if the question is after 20 years, what will be estimated growth, or what will be number of deers in that country, just we will put it here 20, and then we will get the result. So after 20 years, total number of the deers in the country, if we wanna